Today, we have an explosive update on the Titanic sub disaster that has shocked the world. Legendary filmmaker James Cameron, known for his work on the iconic movie Titanic, has revealed new and startling details about the recent submersible tragedy. Number 1. Structural concerns. Carbon fiber composites can fail in different ways compared to metals such as titanium or steel. At the depths where the Titanic rests, approximately 3,800 meters below sea level, the pressure is immense. Unlike metals, which typically deform before catastrophic failure, carbon fiber can fail suddenly and without warning. This characteristic is particularly concerning for submersibles designed to operate in such high-pressure environments. Prior to the disaster, several experts had voiced their concerns about the use of carbon fiber in the Titan's hull. They highlighted that while carbon fiber is advantageous for reducing weight, its long-term durability under cyclic loading and high-pressure conditions is not as well understood as traditional materials. Repeated pressurization cycles can lead to the development of micro-cracks, which can propagate over time and potentially cause sudden structural failure. Questions have been raised about whether the Titan sub underwent adequate testing and validation. Rigorous testing protocols are essential to ensure that a submersible can withstand the pressures it will encounter. There are indications that the tests conducted on Titan might not have fully simulated the harsh conditions at Titanic's depth. Industry veterans have suggested that OceanGate may have underestimated the complexities and risks associated with using carbon fiber for deep-sea exploration. When comparing Titan to other successful deep-sea submersibles like Alvin or James Cameron's Deep-Sea Challenger, significant differences in material choices and design philosophies are evident. These submersibles typically use metals such as titanium, which have proven reliability and predictable behavior under extreme pressure. The choice of such materials is driven by extensive research and experience, underscoring the importance of conservative engineering practices in deep-sea exploration. Historical data from various deep-sea missions provide valuable insights into material performance. Submersibles constructed with traditional materials have shown a lower incidence of catastrophic failures. The lessons learned from these missions highlight the critical importance of material selection and the need for a conservative approach when human lives are at stake. While innovation in material science is crucial for technological advancement, it must be balanced with safety and reliability. The use of carbon fiber in Titan was an innovative choice aimed at pushing the boundaries of deep-sea exploration. However, this innovation also introduced new risks that might not have been fully appreciated or mitigated. Cameron and other experts argue that while it is essential to push the envelope, it should never be at the expense of thorough testing and safety. The consequences of structural failures in deep-sea submersibles are severe. A failure at such depths often leads to immediate implosion, leaving no time for escape or rescue. This reality makes it imperative that every aspect of a submersible's design and construction is meticulously planned and executed. The Titan disaster serves as a grim reminder of the potential consequences of overlooking critical safety warnings and the importance of stringent engineering standards. In light of the Titan disaster, there have been calls for more rigorous regulations and oversight in deep-sea exploration. The lessons learned from this tragedy highlight the need for comprehensive testing, conservative material choices, and the importance of heeding expert warnings. Future designs must prioritize safety and reliability, incorporating lessons from both successful missions and tragic failures. Number 2. Lack of regulation. The issue of lack of stringent regulations in deep-sea exploration has been a critical point of concern raised by James Cameron and other experts. Unlike industries such as commercial aviation or space travel, where strict safety protocols and regulatory oversight are in place, the realm of private submersible operations remains comparatively unregulated. This regulatory gap can lead to significant risks and potentially catastrophic outcomes. One of the main problems identified is the absence of a unified regulatory framework that governs the design, construction, and operation of deep-sea submersibles. In the aviation industry, for instance, aircraft must adhere to rigorous standards set by authorities such as the Federal Aviation Administration (FAA) or the European Union Aviation Safety Agency (EASA). These standards cover everything from material selection and structural integrity to pilot training and emergency procedures. In contrast, the deep-sea exploration industry lacks such comprehensive oversight. This lack of regulation means that companies can sometimes proceed with experimental designs and materials without undergoing the extensive testing and certification processes mandatory in more regulated fields. For example, the use of carbon fiber in the Titan submersible's hull, although innovative, did not undergo the same level of scrutiny that a new material in the aviation industry might face. This gap allows for potentially unsafe practices to go unchecked, increasing the risk of failure during deep-sea missions. Additionally, the training and certification of personnel involved in deep-sea exploration are not standardized. In regulated industries, operators and crew members must meet stringent qualifications and undergo regular training to ensure they are prepared for emergencies. The lack of similar requirements for submersible operators can result in inadequate preparedness for the unique challenges of deep-sea missions. The consequences of this regulatory deficiency are evident in the aftermath of incidents like the Titan disaster. The absence of mandatory safety protocols and oversight can lead to preventable tragedies. Experts argue that establishing a regulatory body for deep-sea exploration, akin to those in aviation and space travel, is essential. Such a body would set and enforce safety standards, conduct regular inspections, and certify both the submersibles and their operators. Number 3. Comparisons with other expeditions. Comparing the Titan mission with other successful deep-sea expeditions highlights significant differences in safety protocols and testing rigor. Established deep-sea missions, such as the Alvin submersible and James Cameron's Deep-Sea Challenger, have set high standards in terms of material selection, testing, and operational procedures. Alvin, operated by the Woods Hole Oceanographic Institution, has been in service since 1964 and has completed thousands of dives. Its design incorporates titanium for its pressure hull, a material chosen for its known strength and reliability under extreme pressures. Alvin undergoes regular overhauls and upgrades, and its systems are meticulously tested before each mission. This thorough approach ensures that any potential issues are identified and addressed well before they can pose a danger to the crew. James Cameron's Deep-Sea Challenger, used for his historic solo dive to the Mariana Trench, also followed stringent design and testing protocols. The submersible's pressure sphere was made from specialized materials designed to withstand the immense pressures at such depths. The engineering team conducted extensive simulations and physical tests to validate the integrity of the design. Cameron himself emphasized the importance of multiple redundancies and fail-safe mechanisms to ensure safety. In stark contrast, the Titan submersible's use of carbon fiber for its hull material, while innovative, lacked the same level of rigorous testing. Carbon fiber's behavior under the cyclic loading conditions of deep-sea environments is not as well documented or predictable as the metals used in Alvin and Deep-Sea Challenger. The Titan's testing procedures have been called into question, with some experts suggesting that the submersible did not undergo the same level of scrutiny as its counterparts. Furthermore, operational protocols for Alvin and Deep-Sea Challenger include comprehensive training for the crew and detailed emergency response plans. These submersibles are operated by teams with extensive experience in deep-sea missions, ensuring that every aspect of the dive is carefully planned and executed. The Titan mission, however, faced criticism for potentially inadequate training and preparation, contributing to the tragic outcome. The importance of adhering to established safety standards cannot be overstated. The rigorous protocols followed by Alvin and Deep-Sea Challenger have been developed over decades of deep-sea exploration, incorporating lessons learned from both successes and failures. These standards serve as a critical benchmark for ensuring the safety and success of deep-sea missions. Number 4. Public reaction. The immediate response from the public highlighted a glaring gap in the regulatory framework governing private deep-sea expeditions. Unlike the aviation and space industries, which are heavily regulated, deep-sea exploration lacks comprehensive oversight. This discrepancy has fueled demands for a regulatory body to enforce safety standards, conduct inspections, and certify submersibles and their operators. People are calling for an end to the largely self-regulated practices that currently prevail, advocating for a system that prioritizes passenger safety over exploratory ambitions. Platforms like Twitter, Facebook, and Reddit have seen an explosion of discussions and debates regarding the incident. Users have been vocal about the perceived negligence and the need for accountability. Many argue that companies involved in deep-sea tourism should be subjected to the same rigorous safety protocols as other high-risk industries. This sentiment has been echoed by various influential figures and experts, further amplifying the call for change. Mainstream media has extensively covered the disaster, with numerous reports and interviews featuring experts who have criticized the current lack of regulation. These discussions have brought to light previous warnings about the Titan submersible's design and the use of materials like carbon fiber, which some experts had flagged as potentially unsafe for the pressures encountered at Titanic's depth. The media's focus on these aspects has shaped public opinion, leading to increased scrutiny of the practices and decisions of companies like OceanGate. Beyond the technical and regulatory discussions, the disaster has evoked strong emotional reactions. Families of the victims, alongside the general public, have expressed profound grief and anger. This emotional response has fueled a broader movement advocating for stricter regulations to prevent such tragedies in the future. The personal stories of those lost in the disaster have humanized the debate, turning it from a technical discussion into a poignant call for meaningful action. The public outcry has also had a tangible impact on the deep-sea tourism industry. Potential customers are now more cautious, with many questioning the safety measures of private companies offering such expeditions. This increased scrutiny could drive industry players to adopt more rigorous safety protocols voluntarily, even before any formal regulatory framework is established. The reputational damage suffered by OceanGate and similar companies underscores the high stakes involved and the urgent need for reform. Prominent figures in the field, including James Cameron, have lent their voices to the chorus calling for change. Cameron, with his extensive experience in deep-sea exploration, has criticized the lack of regulation and emphasized the importance of adhering to proven safety standards. His insights have resonated with the public and added weight to the argument for stricter oversight. The disaster has also attracted international attention, prompting discussions about global standards for deep-sea exploration. Countries with advanced maritime capabilities are now considering collaborative efforts to establish and enforce international regulations. This global perspective reflects the universal importance of ensuring safety in deep-sea tourism, regardless of the operator's nationality. Cameron's revelations, along with insights from other sources, underscore the importance of stringent safety measures and regulations in deep-sea exploration. They serve as a grim reminder of the risks involved and the need for thorough scrutiny of technological innovations.